record part 2 of this lesson. Okay, so the derivative of the sine of x is equal to the cosine of x. And if you draw yourself, I like to try to do this. My sine of x is a graph that looks like this, and it continues on, right? See if you can find a pen of another color and try to think about what that looks like. Because here, where my derivative is equal to 0, here is my derivative. Here, when my derivative is equal to 0, it's 0. Here, 0. Here, 0. So I have those points, right? Here, where my slope is high at 1, go ahead, give yourself high at 1. So every place that your slope is coming back up, your derivative is 1. Every place that your slope is coming back up, your derivative is 1. Every place that your slope is coming down, it's negative 1. Negative 1. So you can see the cosine graph if you work to connect your dots. So the derivative of the sine of x is equal to the cosine of x. Alright, so see if you can do the same thing that we just showed you with the cosine of x. Go ahead and turn this into a trig graph and start high with your cosine. Every single time that it zeros, every time that you have a flat tangent, every time you have a flat tangent, the derivative is 0. Now, we start going negative, so it makes sense that here is where my derivative is negative 1. Here, where my derivative is positive, it's positive 1. Here, negative 1. Here, positive 1. And that's how Adrian saw the graph of the opposite of sine. So that derivative graph is kind of cool. Do you want to see the graph again? But then it's ours to just memorize. All right. We can derive now the tangent. So the derivative of the tangent, don't forget we can rewrite tangent as the derivative of sine of x over cosine of x. And that puts us in a situation now where we're going to use the quotient rule. So we can go ahead and tell ourselves that we have the sine of x as the function. And don't forget, so here's our function. The derivative of that function is cosine of x. If we have the cosine of x, the derivative is the opposite of the sine of x. So this is just a little note sheet to put out there. So when we go to fill stuff in, we can go ahead and do the quotient rule. So the derivative of sine of x over cosine of x with respect to x is going to be equal to low d high. And what's the derivative of my high? Cosine of x minus high. What's the derivative of my low? Square the bottom and away you go. Alright, so when we simplify that, we have the cosine of x squared. And then negative times a positive, or negative times a negative is a positive, sine of x squared all over cosine of x squared. Now you know when we rewrite this, that's the same as cosine squared x plus sine squared of x all over cosine squared of x. Anybody know trig identity to help me out with this value? Thank you. This is equal to 1. So we wind up with 1 over cosine squared of x. Anybody know a trig identity to help me out with this one? I won't box it so you think it's a derivative. What is 1 over cosine squared of x? You okay with secant squared of x? Yeah? So that means tangent. The derivative of the tangent is going to be secant squared of x. And we just proved that by using the quotient rule. All right. Here's some examples. Finding the derivative of 3x minus 6 cosine x. Because see how this is negative? The derivative of the cosine of x is negative sign. So this is minus this product. So this is going to be negative, and then it's minus a negative, it's plus a positive. You could also think of it, if you wanted to, as that, and then you have a negative times a negative as a positive. Either way, it justifies that sign change. Okay, so for example 1, the derivative of here, and all we're doing, this is our power rule, so off we go. The derivative of 3x is what? And then the derivative of 6 cosine x is going to be minus 6 times, what's the derivative of cosine? So we'll have 3 plus the sine, or 6 sine of x. So memorizing these. Okay, so find the derivative of, do you see the product? And in fact, you can go ahead and rewrite this as 1 over cosine if you wanted to, and rewrite it as a product if you wanted to. We'll go ahead and keep, or do it as a quotient. We'll do it as a product. So y prime is going to be equal to the first times the derivative of the second and the cosecant. We didn't spend time doing that one yet. We did the derivative of the tangent, but we didn't do the derivative of the cosecant. We got to take some time to go figure that out. Are you ready? Cosecant, we're going to write, I changed my mind, we're going to do this as a quotient. I like my way better. You ready? We're going to rewrite this as 5 is equal to, or y is equal to 5, the sine of x. Cosecant is what? Yeah, I don't like this example at all because now I want to just simplify that. See, I just want to call this 5 times cosine I don't like how she has it written here. Can we table this one? Because I just want to cancel these out and call it 0. And I don't think that's what she intended for us to do. We're going to table that and come back to it. Let's talk about this one. And she has us doing cotangent which is not a part of her notes. Why did she do that? Anybody else confused? I feel like we're missing a page of the notes, don't you? Hold on. This is what's not on the notes. Are you ready? We have some more of these. She had us derive these, but she didn't give us a place to write them down. See this box here? Write these following ones down. Because we have these examples, but we haven't derived them. Are you ready? We have sine, we have cosine, we have tangent. The derivative of secant of x is always going to be equal to the secant of x times the tangent of x. The derivative of the cosecant of x is always going to be equal to the opposite of the cosecant of x times the cotangent of x. The derivative of the cotangent of x is equal to the opposite of cosecant squared of x. Those are the three you're missing. So here we have up top sine, cosine, tangent, secant, cosecant, and cotangent. So when we come up here to do this, now that we have this identity as a product rule, we need to buy stock and erasers. The derivative is equal to the first times the derivative of the second, And this derivative of cosecant is the opposite of the cosecant of x times the cotangent of x. I don't know why we don't have boxes to fill in that data. Plus, so the first times the derivative of the second times the derivative of the first, which is going to be 5 cosine of x, times the second, which is cosecant of x. Here's the great news. We can leave that sit. Yay is right. Ready to do the quotient rule down here? Sure. I love your attitude. Thanks, Mrs. Leisure. We love it. Square the bottom and away we go. Low D high minus high D low, cotangent square the bottom and away we go. All right, so here's the deal. If I could get inside her brain about these notes, we justify sine and cosine with the graph. We showed you tangent with the quotient property. Secant, cosecant, and cotangent are left for us to memorize. Or use a cheat sheet that I'll have for you next class. That's the easy thing. All right, here's some easy ones. Ready? Derivative of e to the x. More ones for us to use. E to the x. You're like, wait, what? ln of x, 1 over x, as long as x is greater than 0. A to the x times the natural log of a. I'm going to show you the graph, so we're just getting these down. 1 over x times the natural log of a, and again, x has to be greater than 0. So if we go back to using our cool graph, the e to the x one is kind of cool. Are you ready? So I'm going to hit pause here.